In this lesson, we're going to analyze graphs of polynomials, and this is basically a recap of things that we've done before. So we're going to start out by looking at extrema. So extrema are the maximums and minimums, and maximums are the highest points on our graph, and the minimums are the lowest points on our graph. So right now, in this class of Algebra 2, we can only find the maxims and mins by looking at a graph or by typing in the function into a calculator and using the calculator to analyze the graph. When you go up to calculus, you'll be able to look at the function of the polynomial and then be able to do some math in order to figure out the max and min. But for right now, all we're going to do is look at the graphs. So this first function here is a quadratic. We can see that there's a minimum right here, and that minimum is about, let's say, 1.5, -6. Okay, here we have a cubic function, and we have a maximum right here, and that maximum is -1,4, and we have a minimum here of 2, -2. So looking at another function, this is a quartic function, we can see that there's two maximums. So we have a maximum here and here, so that would be at the points -6, 0, and 2, 0. And there is one minimum, which is right over here, and that's the point -2, -8. So maxes and mins are as easy as looking at the graph and looking for the highest and the lowest points. Okay, next we're going to look at end behavior. So when we learned end behavior the first time, we focused on the quadrants of a coordinate plane. So in the first quadrant, which is the quadrant up here, we know that the x's are positive and y's are positive. In quadrant number 2, x is negative, y is positive. In the third quadrant, x is negative, y is negative. And in the fourth quadrant, x is positive and y is negative. When we're doing the end behavior, that's basically finding out what the ends are doing. And each graph is going to have two ends, a left end and a right end. So we must find the end behavior for both ends. So looking at the left end here, we can see that this corresponds to the second quadrant. And in this quadrant, the x's are getting more negative and the y's are getting more positive. So for our left end behavior, we'll say x approaches -infinity as y approaches +infinity. For the right end point, that's going to correspond to this first quadrant, and x and y are both going to be positive here. So we'll say as x approaches +infinity, y approaches +infinity. Right? So as x gets more and more large, y is also getting more and more large. Okay, so for this end behavior, again, we have two ends. We have the left end and we have the right end. So on the left end, we can see that this is in the third quadrant. So that means x is going to be approaching -infinity as y approaches -infinity. In the right end, we are in the first quadrant, and x would be approaching +infinity as y approaches +infinity. So now we have just a function instead of a graph. So looking at the graph is pretty easy to tell which ends are in which quadrant, and then using that coordinate plane to help us figure out the signs. Now what we're going to do is combine what we did last class and figure out the shape, and then once we know the shape, we can then figure out the end behavior. So we're not going to graph this, we're not going to factor this. All we're going to do is figure out the shape of the ends based off of the degree and the a value. So this is in standard form. We can see that the highest degree is a 4, and we can see that the a value is a +1. So our degree is a 4, which means it's even. Since it's even, it means the ends are going to point in the same direction. Since a is positive, that means the ends are going to both point up. Okay, so up and up. So we kind of want to visualize where this would be on a coordinate plane. So if I were to graph this, let's say, this end's going to be here and here. So whenever we draw our arrows, if we draw an arrow that's up and left, that's going to correspond to the second quadrant. Up and to the right will correspond to the first quadrant. If I drew an arrow that was down and left, that would correspond to quadrant 3, and down and right would correspond to quadrant 4. So without actually graphing this, I can write my end behavior. So the left end would be in the second quadrant. So that means that x is approaching -infinity as y approaches positive infinity. And the right end would correspond to the first quadrant. So x would be approaching positive infinity as y approaches positive infinity. And now this example is in factored form. So to find the degree, we want to look at how many x's we have. So we have 1, 2, 3 x's, so we know this is x cubed. And now we want to look at the a value. Well, all of the x's are all positive, but there is a negative in the front. So this means this is a negative x cubed. So that means that our degree is odd, which means the ends will point in opposite directions. Okay, since a is negative, that means that we're going to end up being negative. So we're going to be starting up, ending negative. So the left endpoint here, that is going to correspond to the second quadrant. So x will be approaching negative infinity as y approaches positive infinity. And the right end will correspond to the fourth quadrant. So x will be approaching positive infinity as y approaches negative infinity. So now we're going to look at the increasing and decreasing intervals, and that's going to be where the graph is going up or down as x increases. So we're always looking from left to right. When we're writing our increasing and decreasing intervals, we need our end behavior as well as our maxes and mins. So we can just fill that in really quickly. We know this left end is going to be x approaching negative infinity, y approaching negative infinity. We know the maximum is negative 1, 4, because we did that earlier. The minimum is 2, negative 2. And the right end is x approaches positive infinity, y approaches positive infinity. Now it's very important that we know we focus on the x values only. So what I'm going to do to make this easier is I'm going to put a little box around all the x's so we know that those are the values we're going to look at only. So as we go from left to right on our graph, the first thing that we're doing is we're increasing. Then we're decreasing. Then we're increasing. So whenever the graph goes up, it's increasing. Whenever the graph goes down, it's decreasing. So increasing is yellow, decreasing is green. So we'll say that as we go from left to right, we're only focusing on the x's. So it's going to be increasing from negative infinity to negative 1. So in this little span between these x values, the line is going up. Then we decrease from negative 1 to 2. So between negative 1 and 2, the line is going down. And then we increase again from 2 to infinity. And again, between 2 and infinity, the line is going up. So notice that whenever we're writing our intervals, whatever number we stop at, we pick up at in the next interval. So we increase to negative 1, so our next interval starts at negative 1. And then we left off at 2, so our next interval starts at 2. All right, so let's look at another example. So again, we'll fill in the end behavior very quickly. So here x and y are both going to be negative. We know that we had a maximum here at negative 6, 0. We have a minimum here at negative 2, negative 8. We have a maximum here at 2, 0. And our other end is x approaches positive infinity, y approaches negative infinity. And again, we're dealing with the x's only. So we're going to box the x's so we know to pay attention to just those. And then again, we're going to look from left to right and see what's happening. So we can see that from left to right, we're going to increase. Oops, I wanted a bigger one. Increase. Then we're going to decrease. Then we're going to increase. Then we're going to decrease. So to write our intervals, we can say that we would be starting from left to right. We are increasing from negative infinity to negative 6. Then we decrease from negative 6 to negative 2. Then we increase from negative 2 to 2. And then we decrease from 2 to infinity. The last thing that we're going to talk about is the domain and range. The domain for every polynomial will be the same, and it will be all real numbers. So that means that the x direction, both left and right, are going to continue infinitely in both directions. The range will be dependent on the degree. So if we have an odd degree, the range will be all real numbers. So we think about when it's odd, the ends point in opposite directions. So that means it's going up and down forever, so all of the y's will be touched. If we have an even degree, that's when we have to take into account the a value. If a is positive, the range is going to be y is greater than or equal to the lowest value, which is your minimum. So if we have something like a quadratic, right, the lowest y value is right here, and everything else is above it. If I have a quartic, let's say these are even, they're the same level, so it would just be that value and above. But if they're not even, you're going to take the lowest one. Okay, so if the a value is negative, then your range will be y is less than or equal to the highest y value, which is the maximum. So again, if you have a quadratic, you have your highest point and it's everything below that. If you have a quartic with even maximums, it's going to be that value and less. And if you had something that wasn't even like this, you're going to take your highest maximum y value. So let's look at these examples. First, we have a cubic function. Our domain for any polynomial will be all real numbers. So remember, there's two ways we can write it. We can write it in set notation or in interval notation. So you can choose whichever one you're comfortable with. If we were doing set notation, it would be x such that x is an element of all real numbers. Or if we're going to do interval notation, that would be negative infinity to positive infinity. The range, because this is a cubic and the degree is odd, again, it's going to be all real numbers. So if we're using set notation, the only thing that's different is that we're going to use y instead of x. So y such that y is an element of all real numbers. Or if we want to use interval notation, again, we'll say negative infinity to infinity. For the second graph, this is a quartic. Okay, so the domain, again, will be all real numbers because that's true for every polynomial. So again, if set notation, if we want to use that, x such that x is an element of all real numbers. Or we can use interval notation, which is negative infinity to infinity. Now the range here will be different because this is an even degree. So if we want to write this in set notation, we'll say y such that, and then we're going to write in inequality that expresses this. So the y values are all below 0. There's nothing above 0. So we'll say that y is less than or equal to 0. Or if we want to use interval notation, we always go from the lowest to the highest. So the lowest y value we have is negative infinity. The highest y value that we have is 0. And because there's no open circles, we're going to use a square bracket to enclose that 0.